So one of the most important AI security disclosures today is not on a frontier model leak, or it's not a benchmark stunt. It's actually a very practical failure in a way AI coding agents are being deployed inside of normal software workflows. Researcher Aonan Guan published a write-up showing what he calls comment and control, a cross-vendor prompt injection pattern affecting Anthropic Claude Code, Google Gemini CLI action, and GitHub Copilot agent. The short story of this vulnerability is incredibly brutal. If an attacker can get text into a pull request title, an issue body, or an issue comment, and an AI agent reads that text while also having access to tools and repository secrets, the agent can be pushed into leaking credentials back through GitHub itself. That's the whole story. Your credentials and secrets in GitHub are no longer safe. They're vulnerable to prompt injection. But the bigger lesson here is more important than the individual bugs. This is what happens when we keep pretending prompt injection is a model behavior problem instead of an architectural security problem. The primary source lays out 3 related cases, and I'll link those sources in the comments. In the Anthropic case, the research says the Claude Code security review action interpolated the PR title directly into the review prompt, and the Claude CLI invocation did not sufficiently constrain tool use. The result was that a malicious PR title could push the agent to run command and surface environment-derived credentials into the generated review output of the comment. In the Google case, the target was Gemini CLI action. The reported issue was that attacker-controlled issue content and comments could be fed into the agent context in a way that let the attacker override the trust framing and induce the agent to post the Gemini API key publicly in an issue comment. The GitHub Copilot case is the most technically interesting in my opinion. The write-up says the attacker could hide instructions inside of a bash escaped HTML. Yes, that's just CLI bash commands wrapped in backticks in a comment within the GitHub issue. Human reviewers would not see the payload in the rendered issue view, but the agent could still parse it. Once assigned, Copilot allegedly executed these commands that allowed the attacker to recover sensitive values from process visible environment state, encode them, and then exfil them through a normal GitHub PR workflow. The same write-up argues that GitHub already has added several runtime defenses, including environment filtering, secret scanning, and outbound network restrictions, and that attack still worked by abusing the allowed path, specifically git push back to GitHub after base64 encoding the output. That is the key pattern here. The attacker does not need a remote callback server. The attacker does not need malware on the runner. The attacker does not need to break GitHub itself. They just need to have the agent treat an attacker-controlled repository text as actionable context, while the runtime still has access to useful secrets and tools. I think this matters because it's a systems failure, not a narrow product bug. I talk a lot about BAC, behavior, authority, and control. This is absolutely a failure in authority. The agents had more access than they needed. And I keep seeing this because it's becoming a very, very dangerous combination. First, the agent has to read untrusted text because that's how modern repository workflows work. The pull request, issues, comments, and attached artifacts are all partly attacker controlled in any open or semi-open development system or process. Second, the agent has powerful capabilities. It may run shell commands, inspect code, create commits, post comments, call APIs, or open pull requests. Third, the agent runs an environment that holds exactly the secrets needed to turn a prompt injection into an actual incident. API keys, GitHub tokens, provider credentials, and sometimes organizational specific secrets. Once those 3 conditions hold at the same time, prompt injection stops being an amusing reliability failure. It becomes a privilege boundary problem. I say this all the time. Me being able to convince your model to tell me how to make a pipe bomb may be embarrassing, but it's not an incident. An incident is when I convince your system to act maliciously, for your agents to act within your environment. That is now an incident. I think that's also why these incidents, these stories are continuing to recur. The model is doing what the development architecture is telling it to do exactly. It's reading context, it's following instruction, and then using tools and operating inside a privileged runtime. If untrusted instructions are in the context and the secret-bearing tools are in the runtime, then the real mistake happens before the model ever produces a single token. I think the broader lesson here is to the industry is that it's still developing agents as if instructions following can substitute for isolation. Listen, it can't. You cannot fix the class of problems by writing a better prompt that says, ignore malicious instructions. That's never going to work. You cannot fix it with one more classifier. You cannot fix it by blocking single commands like PS and declaring victory. The Anthropic mitigation noted in the public record appears to block one concrete command pattern, which is useful as an immediate patch, but is not the same thing as solving the underlying architectural issues. The GitHub case makes that especially clear. According to the disclosure, 3 layers of runtime defenses still failed because the attacker used the path the system was already designed to allow. GitHub hosted collaboration and normal repository environments and operations. So this is where AI security is starting to converge with more familiar security disciplines. It looks a lot like CI. It looks a lot like supply chain trust. It looks a lot like least privilege. It looks a lot like treating every externalized text field as hostile input. These are cybersecurity primitives we've lived and relied on for the past 30 years? And that's exactly how I encourage people to look at it. If you would not hand a shell script direct access to attacker authorized issue, plus repository secrets within that, then you shouldn't hand that to an LLM. It's a bad combination. I think there are a few practical lessons builders should really take away from this right now. The first is separate untrusted context from privileged execution. If an agent must read untrusted PR or issue text, do not let the same execution context hold broad secrets and unconstrained tools. Second, treat repository text as attacker-controlled input by default. That includes titles, descriptions, comments, markdown, hidden HTML components, and any content imported from forks or external contributors. Third, we need to minimize secret exposure really hard. We have to give agents the fewest credentials possible, scope them tightly, and bind them to exact workflows and execution paths where possible. GitHub's own 2026 Actions Roadmap is moving in this direction with scoped secrets and stronger policy controls, which is the sign that platform-level problem is real, is recognized. Fourth, prefer allow list over block list for agent tools. If an agent only needs read-only code inspection, do not give them broad shell freedom or write capability tokens. Fifth, design for exfiltration resistance. Assume an attacker can eventually steer your agent. Build the runtime so that even a compromised agent cannot trivially read or export the highest value material. And finally, stop evaluating agent security like it's mostly about model refusal quality. The harder question is what the model can reach, what context it can trust, and what happens when those assumptions are completely broken. My take is that this story crosses the threshold because it's fresh, public, cross-vendor, and deeply representative of where the real AI security problems are today. Not in some abstract model discourse, not in social media hype, in actual workflows that combined untrusted text, powerful tools, and live credentials. Comment and control is a very, very useful name, but the core issue is older and simpler. If your agent can read attacker text and touch secrets in the same session, you should assume prompt injection can eventually become credential theft. That's the real lesson here. And teams shipping AI agents into software pipelines need to start acting like it. My name is David Campbell. If you're interested in learning more about AI security or AI safety, subscribe and check it out.